So hello everyone, welcome to the first part in a series of videos where I'll show you how to build what I like to call a function wrapper. Now at a very high level, a function wrapper is a little piece of code that we can put around a given calculation function that just makes it that little bit more user-friendly, where for a given function it might be fine if you've built the function, you know its quirks, you know the inputs, you know what you're expecting in terms of the outputs, but when you pass that on to another end user, they don't know this stuff and they can easily get it wrong. So they need a little bit of extra help, and that's what I'm going to learn how to build in this series of videos. Now in this first video, we're going to build our underlying function, and I've chosen the forward price of an asset, which is something like a share or a stock price. We're also going to build a small set of what I like to call a test harness, just to make sure that the underlying function is doing what it should be doing. So let's go straight into the Visual Basic Editor and let's get started. So you can see on screen here the equation that we're going to build for the forward price is shown. We're going to start by just going to our project in the Project Explorer, and we're going to do our usual thing of clicking on the properties, and we're going to give it a sensible name. Let's call it Forward Price Project. Next we're going to add a new module, so Insert Module. And as usual, we're going to rename the module again to be something sensible. So let's call this Forward Price. Let's close down the properties window. Now let's actually start building our function. We're going to say public function, spell that right, forward price. And the return value is going to be a double. And our set of inputs, we're going to start by inputting a spot price. So by val spot price is double. Next we're going to have a start time in years. We've got our expiry time in years. Our risk-free rate. Next we have the storage costs. The dividend rate. And finally, we're going to put in an optional input for the convenience yield. With a default value of 0. Okay, so that's all of our inputs. We use a couple of intermediate local variables. Let's say dim duration in years as double, and dim cost of carry also as a double. And these are just little intermediate steps that I like to use in this calculation. And next we'll start actually calculating those. Let's go duration years equals expiry years minus start years. So this is just the duration that we're actually going to have for the forward price in years. So expiry minus the start, very straightforward. And the cost of carry is risk-free rate plus storage costs minus the dividend rate. And our final forward price is then spot price multiplied by e to the power cost of carry minus convenience yield, and that's multiplied by the duration in years. Very straightforward. Nothing exciting going on there really. It's just a function that I've chosen simply because it lends itself well as an example for what I'm trying to demonstrate in this set of videos, and that is how to build a function wrapper. Next, we're going to build a small subroutine that will just test this forward price function. I'm going to say private sub test forward price. Obviously, we're keeping it private because we don't want the end users to be able to go clicking on this and running it themselves. This is something for the developers. We can say dim spot double dim risk-free rate. So declare all of our variables. So now that we've declared our variables, let's initialize them to sensible values for a known example. And for this, we're going to say, we'll just put a comment in here. We'll say spot equals 100. And we're going to give the storage cost a value of 0. Okay, so let's actually call our function to set a value for the forward price. So forward price and to finish off, let's put in a few comments and outputs to the immediate window just to tell any user that's actually running this function what's going on and what the correct answer should be. Okay, so I've just typed that up, and what we're going to do is try running this test harness just to make sure that we've built our forward price function correctly. So open up the immediate window and clear it out, and then we're just going to press on play. We see here we're expecting a value of 96.08, and we've got something which is very close to that. Obviously, if we did some rounding, we get 96.08. So I'm happy that that function is behaving like it's supposed to. And if we did make any changes, we could just rerun this just to make sure that that known example did work out correctly. And we could obviously add a number of other known examples to test various other features, such as putting in invalid inputs and just seeing what happens. And we'll do that a little bit later down the line. So for now, the last thing we're going to do is to create a similar test harness just within our actual worksheet, so that we can test it from the worksheet side as well as from within the VBA code. So let's go back to our worksheet. And what we'll do is we'll list our various inputs. We'll say so all I've done here is on our worksheet, I've created an input cell for each of our inputs that we need for our function. And in this cell, I'm just going to actually input an equation which uses the function to calculate the forward price. So we'll say equals forward price with our spot, our start years, our expiry time in years, our risk-free rate, storage costs, dividend rate, and finally our convenience yield. And then if I press enter, I get a value which is again what we're expecting, 96.08. So this is our starting point. We've created our underlying function, we've created a test harness in the VBA code, and we've created a test harness in our worksheet. In the next video, we'll start exploring some of the problems with this basic bare bones setup, and then we'll start actually building a function wrapper to go around it and to make it that little bit more user friendly.